Exercise 12 question number 3, y equal fx, then y equal 3fx, then y equal 3fx minus 1. So this is a vertical stretch with scalar factor 3, and this is vertical. After that, this is vertical translation of minus 1. Let's consider uh, a few points. Fx, we have 0 1, and I'm going to consider two lines, x equal to, this is asymptote, and y equal 0, this is also asymptotic. So then 3fx, I'll consider this one also part of a graph, and 2 asymptote also part of graph. So this is 0 1, this x-axis is 0 1. Then when you multiply by 3, so it is affecting to the y values. 0, this is 3, 1 times 3, and it's not affecting to here. And 0 times, if you consider this point, okay, any point on this y equals 0 line, and when you multiply that y value, it doesn't matter, you can consider a0, because we are interested on y in this case. So this value is going to be 3 times 0 is 0. It means y equals 0 asymptote stay the same. X equal to, we didn't do anything. Okay, we'll write x equal to as it is. And then this graph, x equal to stay the same, which is x, and y equals 0 line, which is x-axis, stay the same, and this point become 0 3. And now the translation, 3fx y equal 3fx minus 1. It means we have to bring everything down system by 1. So this is affecting to y value vertical. So this is become 2, x equal to as it is, y equal 0 asymptote become y equal minus 1 now. So if I draw in this graph, so y equals 0 become y equal minus 1, and now this point is 0 2, and the asymptote is x equal to and y equal minus 1. So this point is 0 2. So this is the last graph. By equal fx plus 2 plus 4. So y equal fx, then y equal fx plus 2, and y equal fx plus 2 plus 4. Fx plus 2 is a horizontal translation of minus 2, and this is vertical translation of plus 4. So y equal fx, we consider 1.01 and x equal to 1 asymptotic and y equal 0 another asymptotic. So then y equal fx plus 2. So it is affecting to all x values. The command is given shift 2 units to left. So x plus 2 equals 0, x equal minus 2. 2 units, we have to move 2 units to left. So then it's affecting to all x values, not y values. So 0 minus 2 and 1 and x minus 2, x equal, so 2 minus 2 is x equals 0, 2 minus 2 and y equals 0 as it is. Now we can draw the graph. Okay, another one, y equal fx plus 2 plus 4. It means it's affecting to all the y values. So this is minus 2, 1 plus 4, 5, and x equals 0 as it is. And the asymptote is also move 4 units to up. Basically 2 units to left and 4 units up. This is y equal 4 line, y equal 0 shift is shifted to y equal 4, and now new asymptote is x equal 0. This is x equal 0 line, and minus 2, 5, now it is somewhere here basically. This a point now here minus 2, 5, 2 units to left, 4 units to up. Part C, y equal minus f2x, y equal fx, then y equal f2x transformation, then y equal minus f2x. So this is a horizontal stretch x-axis. With a scalar factor half, and this is reflection in the x-axis. So y equal fx, we have 0, 1 point, and x equal 2 asymptotic and y equal 0, 1. Now y equal f2x. So scalar factor is half, effect into x value. 0 times half is 0. Y value as it is. X equal to become 1. 2 times half is 1. So now new asymptote is x equal 1 and y equal 0 as it is. Then y equal minus f2x. So this is going to be a reflection of along x-axis. So all the x value is same, only y value is change in the symbol, change in symbol. So basically x value is same, 1 become minus 1. X equal x value is same, y become y equal 0, is x-axis stay the same because this is x-axis. Y equals 0 mean x-axis. So we are taking the mirror reflection along x-axis. So it is stay the same. This is this one 0 1 and this is x equal 1. No more x equal 2. Y equal 0 as it is. Now what will happen? The mirror reflection of x-axis. So x equal 1, the asymptote stay the same for this one. And then 0 1, then it's going to be 0 minus 1. Or x-axis, y-axis. Part D, y equal f mod x. So y equal fx, then y equal f mod x. So there are two, we are divided into two parts. Fx value, fx graph x less than 0 and fx graph when fx greater than 0. So we have to consider two areas of fx graph. So this is the fx graph. This is x equal to, so one area is x less than 0 and this is greater than equal. So x less than c area is this one. So what is the command given? Disregard when you draw this one. Then x greater than area. So now we disregard this area. Now the remaining is this part. So we want to get the mirror reflection along y-axis. Reflection of y-axis. So now when we keep a mirror on here, so this point is going to be here. This point is going to be here. This point is going to be here. So this is the mirror reflection of this part. Then the mirror reflection of x equal to become x equal minus 2. And after that this part. It is here from here to here, so it is here to here. Zero 1 point x equal to and y equal 0 asymptotes. So y equal f mod x, then 0 1 is going to be 0 1 as it is. It's going to be here. X equal 2 become x equal minus 2. And x equal 2 also is exist, because this is not the graph, the whole set is graph. So x equal minus 2 and x equal 2 and y equal 0 as it is, which is x-axis. So this is the graph. This is x equal 2, x equal minus 2, and then 0 1 point A. If we consider this is B, so this is the B dash, the shadow of B. If we consider this point is C, then this is the shadow. This is the shadow of C dash. We want to sketch this graph. This is a quadratic graph. To revise you, I will x equal minus 2 square minus 9. So I'll expand this on x square, 4x plus 4 minus 9, then x square minus 4x plus minus 5. So this is the quadratic graph. So to draw the graph, what you usually do, you are completing the square. So what you do from here, y equal x square minus 4x minus 5, then y equal, you get half of this, then you minus 2 square minus 5, so y equal x minus 2 square minus 4 minus 5, y equal x minus 2 square minus 9. That's how we this is the quadratic graph. We complete the square to find the minimum or maximum point, and we know this value is a greater than 1. So this is a positive. So this is a quadratic graph with minimum. Hence y equal x equal 2 is the symmetric line, and so this is x equal 2, and this is y equal minus line. So this point is 2 minus 9 minus 9. Now I want to find y intersect. I don't know if it is here or here. So we know that the y value, x value has to be 0 on y-axis. So from here, when we put x equals 0, so y equal minus 2, 0 minus 2 square minus 9. 4 minus 9, that is minus 5. So then the graph cuts to -5. So this is 0 -5. Now for B, I will take y equal gx, and they have those points. Okay, 2.2 -9 point, and initially we want to find y equal 2 times gx minus 4. So this is y equal gx. So then gx minus 4, then y equal to gx minus 4. So this is a horizontal translation of 4 to right, and this is vertical stretch. Scalar factor 2. So y equal gx, we only consider 1.2 minus 9. So y equal gx minus 4. It means the effect into the x value. So 2 plus 4 and minus 9 stay the same. Then y equal 2 times gx minus 4. So this is 2 plus 4, 6. And this value, y value, this is equivalent to y value, will get double. So this is going to be 6. So coordinate is going to be 6 minus 18. So y equal, this is gx, then y equal g2x. This is going to be a vertical horizontal stretch of scalar factor half. Y equal gx, so we have the point 2 minus 9, and y equal g2x, then it is we have to multiply the x value by the scalar factor, which is half. So then this is going to be 1 minus 9. Y equal gx total mod dwelling. So y equal gx, then y equal mod gx. So what will happen here? We are considering two areas. Gx graph, gx when y less than 0, y greater than or equal to 0. So gx graph, y greater than or equal to 0. So this is the area. It means in terms of graph, this part stays same. Then gx, where y less than 0. So this is a mirror reflection of x-axis. So for only this area, the graph behavior is the mirror reflection of the graph. So in that case, graph is going to be something like this. So 2 minus 9 become 2, 9. So y equal gx, then y equal gx 2 minus 9, then mod gx mean put all the mod value to y, to mod minus 9, which is to uh, positive 9. Basically, let's say consider this point is AB, this is CD, this is EF, this is GH. So now we have AB, CD, EF. We consider only 4 points, GH. Now when we take the mod value, so we apply mod to y value because it is affecting to the y value. Make all y's positive. That's the command. C mod D, E mod F, G mod H. Now when you look at B, yeah, B is always positive. B is positive, so it is still positive. But when you look at D is negative value here, so this D is become positive. Let's say C alpha. So this become positive, so it's come here. Then EF, F value is a negative. So then see this F become beta here. It's changing. And G, H is already positive, so it doesn't matter. There's no value of mod for H because A already positive, so H as it is. Part C, y equal G mod X. Then y equal Gx. Then y equal G mod X. So what is happening here? As we discuss, Gx graph where x less than 0. We have to disregard. And Gx, the Gx graph where this is Gx, x greater than c or equal to 0, reflection or mirror reflection of y axis. Now we have to disregard this area. So this is 2 minus 9 less than 0, disregard. And Gx greater than this area, we have to get the mirror reflection. So this point is as it is. So 2 minus 9 become minus 2 minus 9. Assume this point is alpha 0, then this point become minus alpha 0. So y equal Gx 2 minus 9, right? So y equal G mod X is minus 2 minus 9. We need to identify carefully the message given these two. Y equal Gx mod and y equal G mod X. In here the message is make all y values positive. So by looking at this, if we are trying to do this one, make all x values positive, that doesn't work, because in here, for same negative or positive x value, provide same y value. For same negative or positive x value, the x value should be same. So x equal, actually, of magnitude, magnitude size, for same size. So x equal to, the magnitude is 2 and the value is positive, give the same y, which is minus 9. So the magnitude is 2, and for the same magnitude and only the difference is negative, give the same y value, minus 9. For another example, assume this value is 1, x value is 1, and you will get 1, let's say minus beta. So this minus beta. So this expression say even x equal minus 1 or give the same y value for x equal minus 1 as well. So x equal minus 1, the same beta value. Question number 5, hx equal 2 sin x graph. Domain is given minus 180, x 180 equal as well. Sketch the graph. So y equal sin x we know. So this is 90, 180 minus 90, 180, and sine graph is going. So this is sine x graph. This is 91. This is minus 90, minus 1. This is 180, 0. This is minus 180, 0. And then y equal 2 sine x. So this is a vertical stretch. We have to multiply y values by 2. So in that case, 1 times 2, 2. It means another. So this is 0 times 0, 0. 0 times 2 is 0. So still graph go to the 0, 0. Then so this is y equal 2 sine x graph, and this will become now minus 90 minus 1, and this is 90 and 2. Sorry, minus 90 minus 2, because minus 1 times 2 is minus 2. So this is O and minimum is A and the maximum is B. So O is 0, 0, A is minus 90 minus 2 and B is 92. Uh, part 1 we have to do y equal hx minus 90 plus 1. So this is a translation, horizontal translation of 90, and this is a vertical translation of plus 1. So we have to shift 90 degrees to right. The graph should shift to 90 degrees to right. So then this minus this one is here now. And this 0, 0 is shifted to here. And this point is shifted to this place. And 9, 2 shifted to here. So it's going to be something like this. So that is 90 degrees to, so this is hx minus 90. And then we have to bring one up this one, the green graph. So then this value become so this is the line. So according to this one, 92, 90 minus 2 and minus 2 plus 1. Now it is here. Sorry. So this point is 90, 182. Now this is 183. Likewise, y equal hx. We have minus 9, 2, 0, 0 and 92 minus 9 minus 2. Then y equal hx minus 90 plus 1. So shifted 90 and up 1. So this is for x values, this horizontal translation. Minus 90 plus 90, 0, 0 plus 90, 90, and 90 plus 180. And from here, we are adding 1 to this one. So minus 2 plus 1, 1, 0 plus 1 is 1, 1 plus 2 plus 1 is 3. So those are the changes. The other one is y equal 1 over 4h half a x. So this is a h half a x is a horizontal stretch with the scalar factor 2. So we have to multiply all the x value by 2. So this is 2 times 0, 0, 90 times 280, and this is going to be 360. And the vertical stretch is 1 over 4. So all the y values multiply by 1 over 4. So this is 1 times 1 over 4, 1 over 4. So this is also, okay, from this graph. I think I want to turn this one, not this one. So let me delete this one. And then it is easy. Now this one. So those answers should wrong because I turned the wrong graph. So when you look at now, the scalar factor is 2. It is horizontal stretch. All the x values we want to multiply by 2. Minus 9 times 2 minus 180. This is 0 times 2, 0, and 90 times 280. And the y values now we want to uh, multiply by 1 over 4 or divide by 4, both same. So minus 2 divided by 4, which is minus half, and 0 divided by 4, 0, and 2 divided by 4 is again half, minus half, positive half. And the other one is y equal half a mod h minus x mod. Yeah. So first of all, we'll consider the mod. So what is the message we discussed? Turn all the, so this is first of all minus x. There are two operations. So I'll consider minus x first before take the mod. Y equal h minus x. So this is a reflection of y-axis. So in simply, if there is a point here, how do you bring this point to here? The mirror reflection. It means y value is stay the same. The x value, if this is alpha minus alpha, so we have to make it to positive alpha. The same as if the point is here alpha, then we can bring into here by introducing minus or multiplying by minus, or negative to positive, positive to negative, all the x values. Minus 90 become positive 90 and 0 as it is. This 90 become negative 90 and and uh, this one as it is. Now y equal mod h x. What is the task of this mode now? The task of this mode now, turn all the y values to positive. So this is y value negative to positive. So this is positive, stay as it is. Minus 9, the y value is positive, stay as it is. Then y equal half h minus x. And this message is half all the y values. So 91. 0, 0 divided by 2 is 0. Minus 92 divided by 2 is 1. This is the graph for this one. B, O, 91, and A, 0, minus 1. So this is the this one, y equal 1 over 4 half x. A is minus 180 half, and this is 180 half, and 0, 0 as it is. Now this graph, what is happening here as we discussed, this is the graph, hx graph. Then h minus x mirror reflection. Mirror reflection of this part is going to be like this. Then that's part done. The mirror reflection of this part is here. Now this is the graph. Now we want to introduce mode value. Make all y value positive. Okay, this is positive. This is y negative. So turn into mirror on x-axis. Okay, that's done. Now half. It means make the y height all the coordinates, the y value of coordinates, all the y value of all the coordinates, make it half. So basically if this is the maximum, so maximum half here, others also half. So the graph is going to be here. This is the graph is this. In the original graph, so minus 90, minus 1, so 91. So this is the graph of this one. Then the mirror reflection. So, minus 91, this goes to here, and this one to here. So it becomes 90 and 1. So this is done now. Now this part, mode value. So bring this negative minus 1 to positive. So now it is 90 and 1. So now we are here. Now make it to half. So 91 divided 1 times half is half. So same way, this is minus 90 half. I think I have to do a correction because graph is 2 sine x. So this is 90 and not 1. This is 90 and 2. So if I quickly go through again with this one. So this is minus 92, 0, 0, and 92. So then this is hx. So the mirror reflection. So this part is going to be here. And this is become minus 92. And this part is going to be here. So this is become 90 minus 2. Now this is missing. Now we are here. Now made everything to positive. In that case, this is the only part. Made all y value to positive. So it will come like this then. So 92. And then we want to make half it. So then all the y values turn into half of previously. So 2 become 1. So 90 and 1 and minus 90 and 1, because why? 2 times half is 1.